Greetings, Earth enthusiasts. If you ever wondered about the incredible perspectives our planet has to offer from high above, you're in the right place. I am Dr. Clive Coetzee, and I'm thrilled to be your guide on this captivating journey into the world of remote sensing. Welcome. And please remember to like, subscribe to, and share this video. Thank you.
In our previous video tutorial 74, we generated our time series for each of those 100 points. Remember, we created roughly 100 points, well, exactly 100 points, roughly divided equally between locations that most probably would have had snow within this time period and locations which most probably would not have had any snow over this period. So basically two groups. The snow group and a non-snow group. And then we generated the data in time series format for each of these 100 points. Daily data, remember the data product is daily, so it's daily data from February 2000 to December 2023. So that's a lot. We can count how many observations that is now. Okay, so that's what we did in our previous video tutorial. And this is a script for it. So if I run the script, you'll see at the end of the script, we said, okay, generate a CSV file for us for those 100 points. Remember, these are the 100 points. Let me just open up. Remember, these are the 100 points. Remember, they're not random. They're specifically located or specifically chosen because they fall either on either one of those two categories. So those are my 100 points that we've generated and then created, and then we generate the time series for each of those 100 points. A daily basis from beginning, you can see here, it's on a daily basis from 2000 to December 2023. It's a snow cover. It covers the whole period, so that's the daily basis. And we don't obviously reduce it, etc., etc. And remember, we've created that column point where all the data is then stored. Okay, so we've generated the 100 points, we've created the script, we've generated the time series for each of those 100 points. Okay, now what we want to do now is to play around with this spreadsheet and see what it looks like and potentially what we can do with this particular spreadsheet. So we go to our task function here on the right hand side. You see there is the table, or there's the spreadsheet, and you basically just click on run. Now, I'm not going to run it. I've already run it, so I'm not going to run it. But for you, just press run, and once it's done, it will take about, in my case, I think it took, let's have a look and see, it took about 12 minutes. You see, this is the snow cover, the NDS snow cover. Remember, it's NDS snow cover, not the points one. It is the NDS snow cover. There's one here. Okay, so that's the one that we need to run. So it's unsubmitted. You click on run, and once it's done, it will lie here. Now, there's our NDS snow cover. It took roughly 12 minutes to upload that file or to download it. Where will it download? It will download in this project folder within my Google Drive. Okay, so if we go to our Google Drive, go to my project folder, there it is, and there is the snow cover spreadsheet or the data set. Okay, there it sits. Okay, so I just simply go and I download it. Okay, and you download it to your laptop or your desktop or your external hard drive, wherever you want to download it. And I've already downloaded. There it sits. Okay, it's already downloaded in my project folder. So that's the extent to which we're going to use in this video tutorial, make use or reference Google Earth engine. The rest, as I said, we're going to play around a little bit in Excel. Okay, so it's sitting in my folder. Okay, so in my folder here, there it sits. There's a snow cover. You can see it's about 3 megs, 3.5 megs. Okay, so if I open this, it will look, it's a CSV file. It will look something to this effect. Numbers all over the place. You may not think what's going on here. Remember, this is CSV, so what we have to do is we have to stand on column A and just left click on that column and it highlights the whole column. You go to data and you go to text, text to columns, meaning we're converting it now from CSV into Excel using the text to columns. Okay, so just once you've opened it, you left click on column A, because remember all the data sits in column A. Okay, there's nothing in column B. So if I go to column B, you see there's nothing. Nothing. So everything sits in column A. So what we want to do, obviously, now spread it. So I'm sure you guys are familiar with it. So we left click on that. We go to data. We go to text to columns. We go to delimited. We go to next. Remember, it's comma delimited. So press on comma. And you see there now it's split it into its different columns based on the comma. And we basically just click on finished. Okay, and there it sits. Okay, all the data. Now it does take a bit of making nice, making it pretty, and a couple of things. So play around with it. But in general, what we can do now is we can save it as an Excel spreadsheet. So I just go, I go save as. I put it into my tutorial wherever I want to save it, and I don't save it as a CSV file, but I save it as an Excel spreadsheet. Okay, so I've already saved it, so I'm not going to save over it, but you save it as an Excel file. Okay, so there's my CSV file, and then let's close that. I'm not going to save it, and we basically open our open it in Excel. Okay, and this is what it will look like. Okay, this is what it will look like. It will have that ID numbers there. That it generates. So if we go into Earth Engine, let's have a look and see if on our console, you'll see there's the ID numbers, you see. So each one will have, let's just go, it will have that number there, 2002-24, and then a whole lot of zeros. Go spreadsheet. And then it says 2201, a lot of zeros, and you see it goes from 1, 2, 3, etc., etc. And then 1A and 1, it's all sorts of fun in it. This is rather irrelevant for our purposes. So you can actually just delete it. For my sake, let's just hide it for now. There is the dates, 24 February 2000, 25th February 2000, 26th February. So that's the daily basis. Now you can convert this into date by taking the underscore and put a / in, and then converts it to a date. Now it's just a number. Okay, so we'll do that a bit later. So that's how it comes from. And then to the end of the spreadsheet, you'll see it will have two last columns. The two last columns will have the point. Remember, that's the column that we've generated with this number. This is again a unique ID number for each of these locations. So that's location 079, that's location 001, that's location 052, location 047, and its data. And then each location has a centroid, has coordinates. It has an X coordinate and it has a Y coordinate. Okay, so that is now the data that we've taken from CSV and we converted into Excel, and then we just made it pretty a bit. Okay. Change the column size, the headings, make it central, justified, made sure there's no errors, etc., etc. So took a bit of time, almost 2 hours, 2 hours from the CSV to here. Took me almost 2 hours to do this. So in many cases, it does take a bit of time. It's not just press the button and voila. It takes a bit of time to go. But it's important because you don't want to do all the work and then come back and say, oops, there's somewhere a mistake. So take your time, make sure the database is perfect. Okay, as I said, in my case, it took 2 hours, but rather spend the 2 hours up front than spending 2 days at the back. Okay, so that's the point that we've generated in our script that allocated a unique number because it's a random number. And it attached the time series to each of these random numbers, which then, and each random number has a X and a Y, which is the lat and the long, or the long and the lat, which means that specific point. So I've created this, okay, from CSV to this, okay, from CSV to this. Now it's not a time series format because the time series runs in rows. Okay, remember time series in Excel is in columns. So basically, we're just going to basically copy this whole thing. And we're going to basically go to this and we're going to go by special. By special. Come on. paste special, and we're going to go values and transpose. Remember, we're going to transpose it so that we shift the two axes. The y-axis becomes the x, and the x-axis becomes the y. So we're moving it now from this format where the date is on rows and to this format where the date is in column, meaning to time series. So it's just a transpose, paste transpose. Then I've added 3 columns, which is a year column, a month column, and day, and that's just to, if we want to average the data to daily format, to a yearly format, or we want to sum it for a year, or whatever the case might be. When I work with time series, specifically such a high frequency like daily data, I like to add in these sort of things, and we play around with it. Now, and then obviously there's locations, okay, and there's the years. So let's quickly just see how many data points or observations are there. Okay, so we're going to go and say equals count, and we're going to say count the number of cells and arrays that contain numbers. Okay, so I'm going to do this. So let's do that. So that's the bottom there. And we're going to go to whole to the right, and we're going to go to this. And we're going to close the bracket, and we're going to press enter. 901,000, let's call it 900,000 observations. Now that's a flippin' beep, 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 beep number of observations. That's quite a large databases. Now in most programs, you're not going to be able to run this. So QGIS, Excel, even Excel, you're going to struggle to work with this. So this is in a daily format. So you either convert it into weekly format, which I think would still be problematic, or you have to convert it into monthly format, because you're going to struggle to work with this in any databases, because 1 million observations, it's a lot. You need a lot of computing power. My system, it's not going to take it. Okay, so that's problematic for me. And I've done it, tried to put it in a pivot, but the pivot only takes about 2 years worth of daily data, and then it stops. So you can't even do a full pivot with the data. Okay, so what I've done is to say, okay, let's convert this data into months. Okay, so rather than each day per month, let's just do an average per month. Now you can do a sum, or you can do an average. Now I've done an average simply because the February's only got the last 4 days. So otherwise you must delete February. That could be a solution, and then you can do a sum. But that's up to you. So I've done a sum of an average if multiple criteria. So first of all, what I've done is, if I go to the bottom here, first of all, what I've done is I've created my new time series. Okay, and it is, you'll see it's monthly format starting from February 2000. So I've created my months. Okay, so I'm converting it now from daily to monthly. I'm doing it in Excel. And I showed you the reason, because working with 1 million observations, my computer is not going to do that. It's just never going to happen. Excel won't allow it, QGIS won't allow it, none of my stuff will allow it. So I can't work in 1 million observations. So I'm going to convert it into months. Now, you may lose some information, unfortunately, but at least you still have the data, the primary database, the primary data that you can always refer to. So although you may lose some information, they're still there. It's just not captured in the monthly. Although whether it snows on the first day or the last day or the Saturday or whatever day in that month is really relevant, because we've already basically shown that it typically snows in June, July, August. Okay, so I'm creating it, and then I'm creating my 2 set criteria. Second month in 2000, third month in 2000, fourth month in 2000. And then I basically use this. Let's go down again. Formula, and you can convert it to, you can use a sum if you want to. That you can do, or an average. I've used average, but again, you can use a sum. I don't think median has, you can do a median function, but we can try. I don't know. Never done it. Just average or sum. Okay. It's a big thing this now. So you can see this database becomes problematic to navigate. I've got my range, the ones that I want to average, which is my actual observations. My first criteria is C, which is the months. And then my second range is B, which is the year. So I'm using a month criteria and a year criteria. And I then generate the data for each month, the average data for February 2000 for this location, the average data, the average for or snow cover for February 2000 for that location, the average snowfall for February 2000 for that location, and so forth. And I can cross-reference by using my pivot. You can see there's 0.19 and it's 0.19. So now what I've done is I've created basically a monthly data set for my snow cover, and that's now converted from a yearly basis, and I can generate a pivot for that as well. Let's just highlight my data. I've got a pivot. This pivot here is for the daily data, and now I just highlight my data here and I go data and I go insert and I go pivot and I go select my data, new worksheet, and I go to that, put it to the back. Let's leave it for that. You'll see there's the date. We can put the date down there, and there is the data for per year. Okay, so that's the snow cover for that location for each of the years, and it's a sum. You can do it. You can see again 2003, né? And I can do location 2, and I can do location 3. Okay, if I go into the data, there's the quarters. If I go into the quarters, I get the monthly data as well. Okay, and yeah, so play around with the pivot and see what comes from playing with the pivot. Okay, what I wanted to just quickly, if we go back to the daily one, interesting stuff. Okay, so let's quickly add 3 or 4 locations. Okay, remember they are all, we've made them average, so let's quickly make them average as well. Just going to show you something which I found somewhat interesting. So I've got now how many locations average? So we've got 1, 2, 3, 4, 5 locations. These are my first locations, so these are the typical locations that receive quite a bit of snow. So those are not that non-snow locations, these are snow locations. So I just want to quickly go and format, make it a little bit prettier, and wrap it and center it. Okay, so why is that max? It should be average. So that should not be a max, that should be an average. Let's quickly sort that out. Okay. Why are you now? What's happening now with this thing? Average. Okay, so that's my locations. Okay, so there's my 1, 2, 3, 4, 5 locations. Now it's in month and year. So let's take that away and I put it on days. Okay, this is what I wanted to quickly show you guys. Let's make it like that. And average, we can make it sum. Let's make it sum quickly, just to make it stand out a little bit more. And I hope you guys are starting to get where I'm heading with this, and why working in Excel and working in using tool in Excel like pivot are so interesting. Okay, so all are sum. Okay, they're all sum. Now what I want to do, I thought, is there something towards the dates? Interesting to do the dates. Let's quickly go and say, okay, if we, so let's have a look and see if there's particular dates that it snows, or days. or dates when it snows. But typically, does it snow beginning of the month, middle of the month, end of the month, wherever the case might be. Interestingly, on the 8th day of the month, look there, very little snow. 5th day, very little snow in certain locations. But then you look at the 16th. 16th looks like a day that it typically shows. You see there the 15th and the 16th, look there. So around about the middle of the month, it seems, it's typically snow time. And then towards the end of the month again, it typically seems to be snow time. So obviously this is just very, very basic looking at the data. I mean, you have to do quite a bit of statistical work to determine whether snow has a preference. But the initial observations does suggest that snow has a preference. It typically snows around the middle of the month and then to the end of the month. So like in a monthly basis, almost in a cyclical format or cyclical pattern within a month. And you can obviously look at over locations to see whether those are cycles within a location or between locations, etc., etc. Anyway, so I thought that was quite interesting or something to actually explore and to have a look at it. You can see location 1 having doubled the snow of location 2, 3, and 4. So location 1 and 4, quite a lot of snow. 2 and 3, 2 and 5 similar. Third one having the least snow. So you can have a look and see, whether in a particular day it snows like very localized or it snows in quite a large area. So that's interesting. That's what I'm saying. There's such a lot of stuff we can, questions that we can think about, or hypotheses that we can put forward, like just looking at this, is whether snow has a preference, whether if it snows in particular days more or less, whether if it snows in a particular day, is it fairly localized snow or is it snowing in a wide region? So that's interesting questions. Nonetheless, let's move on. So what I've done then is to say, okay, there's my time series. On a monthly basis, I want to go and remember I like Excel and like QGIS. Let's see if I can move it into QGIS. I'm going to move my monthly data into QGIS. So I created another sheet and I had just copy and paste this data in here. So exactly the same. You see there's a date. That's my time series here. It's the date and the locations, the date and locations, and the snow cover. So this is monthly, not daily data. To take 1 million observations to QGIS, my system, never going to work. The only other thing that I had to do then is to generate the centroids. Right, to generate the centroids. So I take the geography that's here to the end. This one here. See Daisy, this one here. The geography here. Hey, that's one here. And I just basically isolate the X1 and the Y1. X is a positive and Y is a negative. And basically I just use a find and select option, or I use my text to columns option. Either one of the two you can use. Okay, so I've created now my X and my Y from my geometry and etc. etc. And so I copy this, this specific stuff, and I created another CSV file and I paste it in there, and there it sits. Okay, and you can see there at the end is the X and the Y. So this is now another CSV. So I start with the CSV, which is daily data. I convert that CSV into a spreadsheet. In that spreadsheet I do a whole lot of things. I put it in a time series format, I convert it into a monthly format, and then the monthly time series I create another CSV and I paste it in there. And what I then do is I go to QGIS, and using the layer, add eliminated text, I basically add in that new CSV file. Okay, which is the one that I've just created. You'll see there's the X and the Y coordinates. But one thing you must please make sure, you'll see in some places there, it says those columns are text. And the reason why they put the columns on text, because in many columns there's just zeros. So if it just is just zeros or very close to just zeros, it assumes it's a text. So make sure you convert this into decimal. So all you do is you go to this little downward arrow. All the ones that says text, you go to downward and you make it decimals. And you make them decimals. Make sure you make all decimals. Because is it text, you cannot use it in QGIS. You can only use decimals. Okay. And you'll see it right at the end is the X and the Y. See, there's the 19, the minus 33. We go there. You'll see the minus, the 19 and the minus 33, etc., etc. Okay, so I'm not going to add this. We've already add this. And as soon as I've added, I have saved it as a point vector file. I saved it as a point vector file, going export, save feature as, etc. And I save it as a shape file. And there it sits. Now there's the 100 points. Let's go up, open the attribute table. Okay, let's have a look and see. You'll see they filtered 100. There's 100 points. There they go. From 1 to 100. So there's my 100 points. And there's the snow cover in time series format, meaning for each point, there is a time series. Okay, and then for each month, there is the locations. And there's the data. And as you see at the X, there's the X and Y coordinates. And there's the data. Now, some of these locations have, also remember, snow, and some don't have snow. Okay, so what we can do is we can put this into Excel now. So let's quickly have a look and see properties. Let's go to graduated. Let's choose June. Remember June, July of 23, there was lots of snow. So we know there was snow. I used the ramp color, the Turboland cover, the palette turbo one. And I'm going to use equal interval. I'm going to classify. And I'm going to press OK. And apply and OK. And it should now indicate. So what we can do now is see. So these locations. So this locations here. This one's with the black here, or the purple. It's very slow. That's why I say it's because of a lot of data. So imagine if I had 1 million observations in here. So it's just taking forever now. Why is it doing forever now? Okay. So you can see there I've taken off the basically, let's call it locations with no snow or very little snow. And you can see if we do this, there's the location with the highest snow. Now, let's quickly add in a satellite image. So I go open anywhere on the right, I right click, I go browser panel. And let's make it a bit bigger. Come on, I don't want it there. Let's go. Come on, let's go. There we go, browser panel there. Let's go to S3 satellite, standard satellite. Let's go to layers again. There it sits. Let's move it to the bottom. And let's go in. Now, where's that point there? There it sits. There's those locations. Remember, that's a blue. Remember that dark blue. And obviously, this won't show it because this is not unnecessarily represented, but it shows you the locations. And you can see the amount of snow. Let's quickly intersect. Let's for this do a heat map. So for July, let's go and do a heat map. So again, do the turbo. We're going to do July 2023. Let's do a heat map and see what that looks like. Okay. Let's just hang on. It will display the heat map. And with that, I'm going to end for now. But I hope there's the heat map. Let's now, I want to put I want to basically make this now let's make I want to make it Okay, so that's not going to work. So I want to make it transparent. So let's go to the S3 one and make this one transparent. Come on. Where do I make this not? Oh, there's a transparency. Let's make it transparent. And you can see there you can overlay it. Voila! Magic! What we've done in Earth Engine. Okay. So the point that I want to make with this video tutorial is the link or the interaction between Earth Engine, Excel, and QGIS. And obviously, we can go into R now and all sorts of things, which we will also do. But here we've created, I think, a prime time series data set that we can use now for all sorts of purposes. What I want to do now is we've got monthly snow cover, and I want to add to that data set now climatic conditions, and I want to add to that the terrain conditions. And then let's play around with this, but that's work in progress. Okay, so that's quite neat, huh? Very, very nice. I think this is looking quite chuffed. Okay, well, that's it for now. Let's touch base soon. Let's continue with our journey. It's getting really interesting, and I want to thank you for joining me on this journey. Please remember to like, subscribe, and to share the video. Sharing is caring. I really appreciate your support. Stay tuned. I will see you on the other side.